the deflection by area moment diagram, the first theorem is, write down first theorem, m by ei equal to d theta by dx. M by ei equal to d theta by dx. D theta is equals to m upon ei multiplied by dx. Now this equation is again the same equation that you normally observe in the case of area. Is it correct? So what is this? So d theta by d theta is equals to m upon ei. So let's say this quantity is y quantity, so which is represented on y-axis, and dx is a small thickness. So the right hand side represents a rectangle of height equal to m by ei and thickness equal to dx. If you integrate this from a to b, so suppose you integrate this from a to b, then the left hand side of this equation gives you the integral of theta. Is it theta b minus theta a is equals to a to b of m by ei over the distance dx. Is it nothing but area under this diagram? Correct? And what is this diagram is called as curvature diagram. Area moment equation, we always get the difference between theta b and theta a. So theta b minus theta a is the area between this. So that is the same term. So while finding the slope at any point, you have to select the point a and b such that at one of the point your slope is 0. Then can you find out the slope at other point? So we have a cantilever with a point load. So is the deflection curve for this one is like this. For this one, is a y, that is the deflection at a, is equal to 0. And is the slope at a is also equal to 0. If you draw the tangent here to this curve, correct? This tangent with horizontal will make an slope. That slope is called as theta b. So if you want to find out the slope at the free end, then we must have one more point in the figure where the slope equals to what? 0. So is the point A, we will select as a fixed point. In that case, can we find out the absolute value of theta b? And is this value of absolute value of theta b is the area of BMD, bending moment diagram, divided by EI. Okay? So in your figure, you have to find out one point where the slope will be equals to 0. So we have a simply supported beam and it's a L by 2 and L by 2. And this load equals to W. So is the deformation of this simply supported beam will be like this. Correct? And this will continue. So there is no slope at A equal to 0. And neither the slope at B will be equal to 0. But is this curve become flattened at this point? Where it is flattened? At point C. So what is the slope at C? 0. Then with respect to C, can we calculate the slope at A? Or can we calculate the slope at B? So every time your fixed point will not have a slope. So from deflection curve, you have to approximate where your slope is 0. So with reference to C, we can find out slope at A. But the slope at C is 0. So is it an absolute slope? And with reference to C, can we find out the slope at B? But is the slope at C is 0? So can we find out the absolute slope at B? But by mistake, if you select the point somewhere here, D, and you want to find out the slope between D and A, so this is difference of slope. Is it correct? What you can calculate is theta A minus theta D. Unless you don't know theta D, you are not able to calculate theta A. So to calculate theta D, we have to first go to C. So while solving the problem of the deflection, you have to always identify where your slope is equals to 0. For that one, you have to draw your loading first. Then guess what is the deflection. Guess can be made very well. If the load is downward, naturally deflection is also downward. And where is the support? There is no deflection. Everybody knows this. So in the case of simply supported beam, the maximum bending will occur at center. There is no deflection on this side as well as no deflection on A side. So naturally it will deflect more at this bottom point. So where it is more, naturally the tangent to that one will have a slope equal to 0. Is it correct? So for simply supported beam, we have a slope at center will be 0, and for cantilever at end is always 0. What is the slope? Slope is nothing but the area of the bending moment diagram divided by EI. Then you have to write down second theorem. Write second theorem. Deflection Y is equals to integral A to B x del theta. This is called as first moment. First moment. This equation is same as x bar equal to integral x dA. Do you remember this? This term is called as first moment, and this term is called as second moment. Second moment is nothing but moment of inertia. First moment will always give you centroid. But what is del theta? Is it equal to m EI into dx? What is d theta? Is it m upon EI into dx? So it's the integral A to B x times m EI multiplied by dx. Is equal to x bar multiplied by bending moment. मतलब same लेना है. You have to find out you have to take the same area, but you have to identify where is the centroid of that figure. Okay, I will write here. यहाँ पे check करेंगे. To mark the distance x bar, you have to select the first point where your slope is 0. If your slope is 0 at point A, then you have to mark your x bar from the opposite point, that equal to point B. In the case of cantilever, your SFD will be rectangle, and therefore your BMD will be triangle. And it is known that for cantilever, the point A has 0 slope. So while recording the value of x bar, you have to select the point B. And this total value, if this length is L, is it 2L by 3? Whereas in the case of simply supported beam, your SFD will be first up, then this is UDL will be represented by a single line, and then also up. Whereas bending moment will be parabola. This degree is 0, this degree is 1, this degree is 2. So we have a parabola. But according to the deflection curve, the slope is 0 at point C. So if you want to calculate deflection at point A with respect to C, you have to consider the left area. And since the slope at C is 0, you have to take the distance from point A. That is the opposite of the slope equal to 0. To find the deflection, step number 1, identify a point on a deflection curve where slope equal to 0. Measure x bar from the opposite point. So theta equals to area under BMD divided by EI, or delta, that is deflection, is given by x bar multiplied by area under BMD upon EI is same as x bar multiplied by theta. Now we'll discuss how to calculate x bar and area for different figure according to degree. N equal to 0 for the degree of the rectangle. Area is normally given by 1 upon n plus 1 BH, and x bar is equals to 1 upon n plus 2 times B. So for this degree equal to 0, so area will be equals to BH, and the centroid distance is B by 2, or h by 2. Now we are only interested in b by 2, x bar distance, not in y bar. Now we have a triangle. So what is the degree of triangle? 1. So degree equal to 1. So area will be 1 by 2 times BH. Familiar? X bar. B by 3. B by 3 from height. Is okay? B by 3 from height. So B by 3 from height. Like this. Height is side mein na? So this is B by 3. And if your triangle is like this, then this is H, this one is B. Then this distance is by 3. From height by 3. We have a parabola here, but this parabola is marked like this. So is this area, is it less than the triangle area? This area is less than triangle area. For this spandrel, I use the word spandrel, that is the core is below the triangle, is n equals to what? 2. So what is the area? 1 by 3 of BH. And where is the centroid of this one? Centroid is here. Always measured from height. So what is this centroid? 1 upon n plus 2. Is it 1 by 4 times B? This is 1 by 4 times B. Then what will be this distance? Is it 3 by 4? You remember 1. Do not apply this equation for the remaining part. Is the remaining part here is same as this part? Correct? Is the remaining part is this part? That is this part here. Is it same as this part? Do not apply this equation to this. But is this area plus green area, is it equal to area A? And the total area equal to what? Is it BH? So this is the green area, and is the green area is 1 by 3 BH. Is it equal to A by 3? Area is BH is the rectangle area. So A equal to BH. That is the total area. Is it consist of green area? That is A by 3. So what will be this area? It must equals to 2A by 3. That is this area is 2/3 of BH. Agree? Then what will be the remaining area? That is remaining area is equals to what? 1 by 3 BH. 2 by 3 BH plus 1 by 3 BH is equal to 1 BH. Check this first. Is this area, that is this area, is it equal to 1 by 3 BH? This area is 1 by 3 BH. Then what is this area? 2 by 3 BH. But if I draw my figure, is it a triangle? If I draw my spindle on this side, so is this area is less than triangle area? So is this area is 1 by 3 of BH? 1 by 3 is less than 1 by 2. So is this area is now 2 by 3 BH? Correct? This figure is called as spandrel. This is not a spandrel. The generalized equations are only applicable for spandrel. If you want to write down the centroid for this one, so mark the centroid somewhere here. Always mark your distance from the height side of a triangle. Is this the height H? So if I remove this portion, your figure is this. Correct? So this one is your H, and this one is your base. So this distance is taken as 3 by 8 of B. Remember this value, 3 by 8 times B. So what is the remaining distance? Is it 5 by 8? The remaining distance will be 5 by 8. So let's consider three cases. One case is cantilever with a BM at free end. One case is cantilever with a point load at free end. And one is UDL over the entire span. The span length is L for all three cases. So this figure represents SFD. Since there is a bending moment, the SFD has a 0 value. In this one, we have point load and we are taking the section like this. So for the right hand side, our conventions are downward positive. So this is the value of P over the span L. So this is SFD for point load. And SFD for UDL, so this value equals to WL. Okay. For the first case, the bending moment is clockwise, is taken as negative, and bending moment over the entire span is remain constant. So we get a rectangle and the degree will be equals to 0. The SFD of the point load is a rectangle, so BMD will be a triangle, and the maximum bending moment will be equals to PL. And finally for UDL, SFD is a rectangle, SFD is a triangle, so BMD is a spandrel. Is it spandrel of degree equals to 2. So the deflection curve will be approximate like this, and the slope at point A equal to 0. So all the x bar is to be measured from where? B. Fine. Now what is theta? Is theta is equals to area of bending moment diagram. What is the area of this diagram, bending moment diagram? Is it ML divided by what? EI. Part 1 is over. What is Y? Y at B. What is Y at A? 0. Is it equal to x bar multiplied by theta? X bar you will going to measure from point B or from point A? From point B. Is this x bar is L by 2? So is your value is x bar multiplied by theta. Theta is nothing but area. So is it equals to M L square by 2 times EI. For point load, the BMD is this figure. The maximum BM is PL. So what is theta? The area of bending moment diagram. So what is the area of this figure? Is it 1 by 2? Is it PL multiplied by this length, that equal to what? L divided by EI. So this is 1 by 2. Is it PL square divided by EI? Part 1 is okay. Now this is point A and this is point B. Slope at point A is 0. So we'll measure the distance from point B. The degree is 1. So what is x bar? X bar is 1 upon n plus 2. 1 by 2 from where? From this side. Is it correct? Always from base. मतलब जहाँ पर height लिखे वहाँ से. So this value is 1 by 3. So what will be this value? 2 by 3 of B. So what is y bar? X bar is 2 by 3 of L multiplied by area is 1 by 2. PL square upon 2EI. Is it equal to PL cube divided by 3 times EI. Fine. Now this one is spandrel. Is it correct? What is the area of this figure? What is the area of SFD? Is it 1 by 2? Is it W L square? So what is the area of this figure? Is it equal to theta? The degree is 2. So is it 1 by 3? What is the height of this one? Is 1 by 2. Is it W? L square. And what is the width of this one? Is L. Is it W? L cube by 6. What is missing? EI. I hope you understand this. Now about Y bar. Sorry, not Y bar. It's a deflection actually. Make a correction. This is deflection at point B. And this one is also deflection at point B. Now what is the deflection at point B? Is it X bar? This degree is what? 2. Is it a spandrel? So what is this value? Is it 1 by 4? 1 by 4. You are interested from this value or you are interested from B? B. Is it 3 by 4 times L? So X bar is 3 by 4 times L multiplied by area. Is it W L cube divided by 6 EI? So is it equal to W L to the power 4 by 8 times EI? So numbers are 2, 3, 8. Find out the maximum deflection of the beam. That is at point B. The beam has uniform EI. Is this bending moment of P, is it clockwise? For the right hand side section it is negative value. Is this moment is clockwise? So is this is minus M. This is L. Is the centroid for this figure is to be measured from this side. So for this figure x2 is equal to L by 2. For this figure x1 is 2 by 3 of L from point B, because from point A the distance is equal to what? 0. Is the area of this figure is 1 by 2. Area of BMD, is it 1 by 2? Is it PL divided by EI? Sign is minus because it is going downward. For this one, is area equal to A2? Is equal to ML? Is it minus ML? So minus sign just indicating that the area is downward. So is the total slope is equal to A1 plus A2? A1 plus A2 is equals to PL upon twice EI plus ML divided by EI. PL, the area of this one is PL into L, no? So that is PL square. So this is PL square. Is Y at B is equal to X1 A1 plus X2 A2. Correct? What is X1? Is it 2 by 3? 2 by 3 PL square upon twice EI plus L by 2 of ML by EI. Two by 3 L. So is this equals to PL cube divided by 3EI plus ML square upon 2EI. The message. Now consider a case where we have a UDL over entire span, a point load. So will the SFD, will the BMD of the point load will change or will not change? BMD will not change, but will the BMD for UDL will change? Except BMD for point load is still a triangle, and BMD for this UDL will be a second order parabola, and it is a spandrel. So this one is BMD for UDL. This length is L. What is the maximum value of UDL? Is it 1 by 2? Rectangle, it's like this. SFD will be like this. SFD will be like this. This is WL. L, area of this one is the maximum bending moment diagram. Is it equal to 1 by 2? W, L square. So this UDL has a degree equal to 2. So from this side, what is the value of x bar? 1 by 4. 1 by 4. 1 by 4, no? From height side 1 by 4, from the opposite side it will be equals to what? So x2 is 3 by 4. L. What about area? Is it 1 by 2 or 1 by 3? 1 by 3. Base into height. What is base? Is 1 by 2. W. L square, and this one is L cube. So area equal to A1 plus A2 divided by E actually. If when you are writing EI, actually you have to construct one more figure here. Huh? You have to actually construct one more figure, and that figure will be like this. That is, this is divided by what? EI, and this is divided by EI. Now in my problem, I have stated you that my EI is uniform. So this will not change. But if I say that my beam is like this, is it still a cantilever? Is it a cantilever? But is this beam has the same EI or EI is different? EI is different. So this one is what? 2EI. Okay. Now this is point load. Let's say this length is L and this equals to L. So what about the SFD? SFD will be like this. And what about the BMD? Is it like this? BMD. Is this area this equal to P? No. So is this area equal to PL? Area of SFD is same as BMD. But this time your PL by EI will not be a constant value. Is that correct? So you have to, the value will fluctuate for the first part, and for second part it's simply EI. So you have to modify this figure one more time. And then what is this value? This is PL. This is divided by what? 2EI. So the figure will be deviating something like this. This one is PL upon 2EI. Then it will shoot up. Correct? And finally, what is the value here? Is PL upon EI. Got it? So in the first loop you find here there is one figure. There is no one figure. How many figures are there? 3 figures. 1, 2, 3. Your problem will become more complicated. I will discuss this later on. Don't write now. Let me calculate YB for this. Is the concept of EI is clear? So actually you have to construct one more figure. But when it's uniform, so you can use your BMD itself is equal to curvature diagram. But suppose in the problem EI is different, then construct SFD, then BMD, and then curvature diagram. This is SFD, this is BMD, and then curvature when EI is not uniform. Is okay? Then your answer is correct. Otherwise you may be wrong.